Hello and welcome to the YouTube channel of AI with Vic, and this is the last video in the matrices series in which we will understand Gauss elimination method. We will follow the process of giving a formal definition first, try and solve a couple of examples, and then show it using code samples of Python. We will try and show various types and operations that we have discussed, and the determinants part, and also the Gauss elimination method in the Python code samples. So by Gauss elimination method, let's give a formal definition. Let us consider a system of linear equations something like this: a12 x2 plus dot 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 a1n xn is equal to b1, a21 x1 plus a22 x2 plus dot 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 a2n xn is equal to b2, and so on. And we have a1n xn plus an2 x2 plus dot 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 ann xn is equal to bn, right? The Gauss elimination method basically states that we need to convert this system of linear equations to solve for x1, x2, x1 into a augmented matrix form, which is a11, a12, a1n, b1, a21, a22, a2n, b2, an1, an2, ann, bn. This is the augmented matrix form. We need to perform row operations on top of it to reduce it to a row reduced echelon form of the matrix, right? If you don't know about row reduced echelon form, I will attach the link in the description. You can go through that video. Once we have reduced it to the row reduced echelon form, it can be solved easily, right? So the idea is basically to reduce this whole matrix system to the form of 1 0 0 c1 0 1 0 c2 and so on 1 cn. So basically then we will have x1 is equal to c1, x2 is equal to c2, so on xn. Basically xn is equal to cn, right? So now that we have given a formal definition, we will try and solve a couple of examples with it. So let's consider a system of equations like this first, and then try and solve it. So I will show two examples here. Okay, let's see them. So let's say, for example, we have a system of linear equations like x plus 2y plus z is equal to 6, 2x plus 3y plus 4z is equal to 20, and then 3x plus 2y plus z is equal to 13. The augmented matrix can be written as 1 sorry, this will be, my bad, this will be 1. So the augmented matrix will be the form of 1 1 1 6, and then 2 3 4 20, and 3 2 1 13, right? Now this can be, now we will perform row operations on top of it to reduce it to row or reduced echelon form. Okay, so r2 can be transformed using r2 minus 2r1, which gets transformed to 1 1 1 6 and 0 1 2 8, and this remains same, 13. The next operation we'll perform is r3 minus 3 r1, which gets reduced to 1 1 1 6, 1 1 sorry, this is again 0 1 2 8, and 0 -1 -2 5, right? uh, Now if you have here again, R3 gets reduced to R3 plus R2, which will give us 1 1 1 6 or 0 1 2 8, and this will actually this is -1 here, -2 R3 -3 R1, and this is 3 plus R2. So this gets, yeah, we are good, 0 and 3. Now this system of linear equations, now you can see that it's inconsistent system, as you can observe here. Like if this was all 0, then there would have been infinitely many solutions. Actually, I have talked about this type of solutions, like there are unique solution where there is no solution, and where there are uniquely many solutions, in my video of system of linear equations. I will attach that in the description if you want to go through that again. So we don't have a solution for this type of system of linear equations. It's an inconsistent system, right? So yeah, that's it. Like it's done here. Like it's an inconsistent system, and we don't have any solutions for that. Now let's consider a system of linear equation where we have a unique solutions, right? So let's go through that first. Let's consider this system of equations: x plus 3y plus 6z is equal to 25, 2x plus 7y plus 14z is equal to 58, and 2y, sorry, this is 2y plus 5z is equal to 19. Right, now the augmented matrix form can be written as 1 3 6 25 2 7 14 58 0 2 5 19. Right, now if we perform row operations on top of it, R2 is R2 minus 2R1, which will actually give you 1 3 6 25 0 1 2 8, and this remains same, 0 2 5 19. You again perform R3 and R3 minus 2 R2, right, and which actually gives you the system of linear equations reduces to 1 3 6 25 0 1 2 8, and this changes to 0 0 1 3. Now either you can go from here and reduce this augmented matrix to a complete row reduced echelon form, or you can do a back substitution also here. Like this has reduced this particular system of linear equations, or the linear equations that I'm considering, to the form. Now if you look at it closely, this is x plus 3y plus 6z is equal to 25, right, and then this is y plus 2z is equal to 8, and z is equal to 3. So now by back substitution, like if you try and solve, you have already got z is equal to 3. If you try and solve it, it will give you y is equal to 2, and then x is equal to 1. Like if you substitute it here, this will become 2 into 3 6, 8 minus 6 2, and then again if you substitute the values of y and z here, you will get x is equal to 1, right? So I mean, like, but we will go forward and reduce this complete augmented matrix to row reduced echelon form. So let's go ahead with that. So this again, we will continue on our quest. R1 R3 minus 3 R2, which actually reduces this to, we have 1 0 0 1 0 1 2 8 and 0 0 1 3. We perform the last operation, or the last reduction. You can say R2 is R2 minus 2 R3, which reduces this to 1 0 0 1 0 1 0 2 0 0 1 3. So like, yeah, so we get the same solution as above. We can see here from the last yeah, it's, we have got z is equal to 3, y is equal to 2, and x is equal to 1, right? So this particular system of linear equations has a unique solution here, right? uh, I would again request you guys to have a look at the video that I have, in which I have explained the system of linear equations, and I have shown three types of solutions there. One which has a unique solution, one which has no solution, and the third which has uniquely many solutions. I have shown geometrically also there that how this is possible. Okay, so with this, we come to the end of Gauss elimination method, and we have shown a couple of examples also. One which has got inconsistent solution and one which has got a unique solution, right? We will now go in depth into the code examples. So let's go there. Before we dive into the code examples, I would like to talk about partial pivoting. So partial pivoting, let's first consider these system of equations here. 0.0001x plus 1y is equal to 1, and 1.000x plus 1y is equal to 2. So basically, in Gauss elimination method, we try to convert each of the row element, like for the first row, we try to convert this element into 1, right? And the below into 0. Now, if you try and pivot at this element here, what happens is that the elimination error amplifies by almost by 10,000 times. Why? Because you are trying to divide it by 0.001 here, and this again you divide it by 0.001, which gets amplified into a very large error. Now what partial pivoting says that we actually select from the, let's say for example, from the first column here, like from the first column here, k is equal to 0, the largest element. What is the largest element here? That is this one, right? 1.00x, right? And then swap it with the topmost element. So then it becomes 1.00x plus 1y is equal to 2, and then 0.001x plus 1y is equal to 1. Now now we can proceed with the normal steps of the Gauss elimination method, and then we can try and solve this. So this is what partial pivoting is. It tries to minimize the numerical errors caused by very small elements that you have here, right? So let's now go directly into the code examples. Okay, so for the code example, I will try and demonstrate using a real life dataset, using the California house dataset. We will go and first try and understand the dataset, and we will try and identify the various target and features. We will try and clean the data, standardize the data as much as possible, add a bias column, and build normal equations around it, and then apply Gauss elimination method. We will also try and visualize some parts to give a better grip on how Gauss elimination works, and we will at the last we will try and predict and evaluate, and we will try and show the various feature as summaries there. Now it's important to understand and remember that this particular problem can also be solved by other algorithms like linear regressions. We are taking this opportunity to try and use the Gauss elimination method. So let's first load some libraries here. This is all done in Python. So we import the NumPy pandas and the other few libraries that are very necessary, and then we load the dataset. Let's look at the dataset here, where we normalize and try and understand the target columns. So the data set consists of 1, 2, 3, 4, 5, 6, 7, 8, 9 columns, out of which median house value is your target column, and these are the features based on which we have to predict. So we can understand here that this particular column is going to be predicted, and this could be in millions or lakhs, whichever suits you better. You can take that example, but the idea is that these columns like median income, house age, average rooms, average bedrooms, population, occupancy, latitude, longitude, like basically the location, are to be used as features for this particular column to be predicted. We first standardize the data and normalize the data before moving on. So we will try and show one particular example of swapping also, or the partial pivoting, before delving quite deeply into the Gauss elimination method. We have implemented the Gauss elimination with steps here, and we will run this just, and then we will try and show this for one of the examples, one of the toy examples, to see how does Gauss elimination method works before fully going into the examples. So let's go there. So as we can observe here, just a minute. Yes, so this example we use algorithm that we have already implemented using the Gauss elimination method, to show the partial pivoting. So you can observe here that in this particular column, this particular row, which is here 8, is of the highest value, and this should be swapped with the previous row. Let's see if this happens or not. So you can see, observe here, let's read the figure very clearly. You can see here that the different colors represents the different numbers here, and here it is very dark red, which represents that there is a very high value here, right? And it gets swapped, right, on using the partial pivot. You can see here the partial pivot is happening, row k is equal to 0, I is equal to 0, for being placed from here to here, right? After partial pivot, this matrix becomes this matrix here, right? Great. Now we will go and try and solve the whole problem using the Gauss elimination method. We have already implemented the algorithm here, so we'll just feed in the dataset after basically normalizing it, and we will get the coefficients here. You can see here we have already gotten the coefficients here for different features here: median income, bias, house age, average rooms. So these are the various columns for which we have got the coefficients, and bias is the AXB, the format that we remember as clearly as possible there, right? So you can see here we have set the bias here, right? You can see the augmented matrix also being formed here, and then we go with the forward elimination. We try and do the partial pivoting, and then we finally solve it with the back substitution, right? Okay, once we are done with that, now we will try and observe all the basically the features importance, like which features were very important in deriving the values. So let's say for example these are the features here, right? And we have population, house age, average occupancy. What this particular image means is that, or analysis means that, median income and latitude and longitude are very important in predicting the price of a particular house. These three features affect very much the price of a house, basically the location and the income around that particular location. Average bedrooms and average rooms are basically the third or fourth most important features, right? Now if we move forward, we can now try and understand all the steps that were involved in the partial pivoting, or the in the Gauss elimination steps that led to the solving of the whole problem. Let's see here. So we have actually been able to solve, and here I have demonstrated the first four steps, but they are not four steps. There are many steps here. We will go down and try and see all the steps here as much as possible. Okay. Yes. So you can see here that how many steps were involved to get to the coefficients. Basically, try and reduce using row operations. If you remember in earlier in the video, we talked about row operations. Try and swap the row. Try and basically deduct from each row to make the pivot element. So arriving at those many steps took around. Let's go there and see. Oh, we can see here. Yeah. This is going to take some time. Yeah, great. So you can see here that there were total 45 elimination steps that we took here to arrive at the final result. You can observe that at the end, you can observe that this basically represents one, like these are the diagonal elements which are basically one, right? Basically the pivot elements, right? Through which we can get the values, right? You can see that we start from, like, let's say example, we start from step 1 here, and each of this image, what does it mean is that we will try and understand it from one of the steps here. We'll Let's take this step, like step 3, and try and understand what does it actually mean by going into the details. So what we are trying to do, let's understand it by the picture here, right? We consider the step 3 here, right? What we are trying to do is, like, we are trying to get to one single formula which will predict actually the house value. So now you remember that we had 9 features, like median income, and then latitude, and then longitude, then average rooms, average bedrooms, and so on, right? The idea is that we input each of these value, right? And we get a single price for the house based on these values, like based on the median income, based on the location, average rooms, average price. We get the price of the house. So now this formula actually has 9 unknowns here, like for each of this we need to find the coefficients, right? So basically 8 feature weights plus 1 bias, right? These 8 features plus 1 bias that we need to have. Now let's understand the picture here, right? Clearly, because we have 9 unknowns, right? We build a small, like, square system right here, like for the Gauss elimination method, like a small square system, and this square part is basically 9 by 9, and this is for all the steps that we have, right? We also, like, basically try and stick the answers columns b, right? The formulation, remember, like it's ax slash b, right? Like the x is basically the unknown, so we are eliminating this, so a is b, right? So basically we also stick the answers column right on the right to make it an augmented matrix, remember, like the augmented matrix form that I explained just now, just a couple of minutes ago, like how we arrive at our augmented matrix. So now we have the 10 columns, right? 0 to 8 are basically the feature column, and the column 9 is basically the answer column, or the bias column that you or the answer column that we have, the bias column A, B, right? Now, what does the red color mean here? Like, let's understand the colors here. So basically, the red color indicates a positive number, right? And the blue color indicates the negative number, right? And gray is basically zero, right? And the color bar basically you see is basically the highlighting of the numbers, like how big they can get. Now let's understand this part. What does this mean here? What is this implying here? This basically means that we are cleaning column 0. Column 0. What do we mean that? We mean that at k is equal to 0, we use the top row as the pivot, right? And I is equal to 2 says basically that erase the number in row 2, column 0. Row 2, column, row 2, column 0. Erase this number. Like now how do we erase that? Remember the row operations that we were doing. Row 2 is row 2 minus factor cross row 0. Remember the row operations that we were doing in the on the augmented matrix to reduce it to a row echelon reduced form, and then get the answers. Now that basically makes that 2 0 basically a spot of gray spot, basically 0, right? Now we keep doing this, right? We keep doing this. We keep doing this so that basically it becomes an upper triangular matrix, or basically below this, like everything turns to be 0, right? Every term below the pivot cell becomes 0 here, right? And so on we go to and so on we perform for step 4, step 5, and step 6, and so on, until and unless we arrive at the last step. Like if you look at the last step, right, you can see here, right, all the elements are now on the diagonal sides, like the upper triangular matrix, like that we expected in the Gauss elimination form, and these are basically the answers that you want for each of the coefficients that we get, right? So this is one small example that I have tried and explained from the Gauss elimination method. Remember, we can solve this through linear regression also, and other algorithms that are in place. But since we studied the Gauss elimination method, I thought that it would be a nice thing that we can solve it by a real world example. Okay, so any part which you didn't understand, please comment and let me know. I will try and make it up and create another video and try and make you guys example and shown to you. I will attach the code also in the description in case you guys want to have a look. And please like and subscribe. I know a lot of you guys watched the video. Please give us a thumbs up and subscribe and comment to make it better. Thank you.